Hello, mathematicians. Here is the video for the first review sheet for Unit 3. All right, here we go. So the first question is asking to write a fraction and a decimal that matches each picture. So in this first picture, I see a big old one whole mat. And then I see a little extra, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9. And I'm going to write 9 hundredths. And the reason they're hundredths is because it takes 100 of these to equal one full mat. And if we write that as a decimal, we're going to write a big old 1, and 9 hundredths would be a 9 in the hundredths place. You could think this as well. 1 mat, right there, 0 strips, and 9 little squares. All right, let's look at the next one. I see a big old 2. Do you see a big old 2? And then let's count how many extra little squares there are. I see 10, 11, 12, 13. And remember, it's going to be hundredths because it takes 100 of these little squares to equal a whole mat. All right, the decimal should also have a big old 2 and 13 hundredths. It looks like a 13 and it kind of goes up to that hundredths spot. Okay, let's keep going. Greater than, less than, or equal to. Remember, if the denominators are not the same, I hope you're saying make them the same. All right, so I see one fraction that's in twelfths. Let's make the other fraction into twelfths as well. To make a 4 into 12, I'm going to multiply by 3. And if I multiply the bottom by 3, I have to multiply the top by 3, and I get 9 twelfths. All right, now I can compare 9 twelfths versus 5 twelfths. 9 twelfths is bigger. You also could think 3 fourths is more than a half, and 5 twelfths is less than a half, so this first one is bigger. Okay, let's go right next door. If the denominators are not the same, make them the same. If I double the top and double the bottom, I will make an equivalent fraction that is also in eighths. What's bigger, 2/8 or 2/8? They are equal. Okay, again, if the denominators are not the same, make them the same. I can multiply the top and bottom by 10. I'm just going to go ahead and add a 0 to each one to show that I multiplied the top by 10 and the bottom by 10. Okay, now I can tell which one's bigger, 45 hundredths or 60 hundredths. You could think of a test. What's a better score, 45 or 60? 60 is a better score. Again, if the denominators are not the same, let's make them the same. If we double the top and double the bottom, I get 6 sixteenths. And now that the denominators are the same, it's easy to tell which one's bigger. Sorry, this is having such a focus issue here. All right, what's better, 4 sixteenths or bigger? 4 sixteenths or 6 sixteenths? 6 sixteenths is bigger. All right, again, if we make both of these have a 100 in the denominator, so if the denominators are not the same, make them the same. And if I multiply the top and bottom by 10, 7 tenths is the same as 70 hundredths.
We have leftover burgers, fries, and soft drinks in 437.39. Leftover burgers, fries, and soft drinks in 437, 439 for the taking.
Okay, and I can see that both the left and right side are the same. Okay, if one of them goes up to the hundredths place, add a 0 so the other one goes up to the hundredths place, and I realize that both of these are exactly equal. All right, 33 hundredths, let's see. Let's go ahead and add another 0. Make them as similar as possible. And you could think maybe money. Sometimes kids find it helpful to think of money. What's bigger, 33 cents or 40 cents? 40 cents is bigger. So don't forget to add zeros. It makes it really easy, or makes it easier to compare. All right, these ones both go up to the hundredths place. So maybe, again, think money. What's bigger, 2 hundredths or 20 hundredths. Is there a difference between a 2-year-old and a 20-year-old? Gosh, I hope so. Okay, let's keep moving. It says write each fraction as a decimal. 68 hundredths. It should look like a 68 and kind of go up to the hundredths place. Okay, if you had 68 out of 100 pennies and you wrote that as money, it would be 0.68, 68 cents. Okay. 3/10 means a 3 in the tenths place. Now, I would just write this. However, if somebody put a 0 after it, mathematically it still would be the same. So I would accept it. But for 3/10, I probably would just leave it like that. Why do more work if you don't have to, right? But that would be acceptable as well. Notice that the 3 is in the same spot. Okay. 1 and 55 hundredths. I see a big old 1. Do you see a big old 1? And 55 hundredths would look like a 55, and it would kind of go up to the hundredths place. Now be careful on this one. This says 3 hundredths, not 3/10. So that 3 needs to be in the hundredths place. So that 3 needs to be pushed all the way to the hundredths spot. All right, the last section says now write each decimal as a fraction. That 8 is in the tenths place, so we're going to write 8 tenths. I see a big old 1, so I need a big old 1 in my fraction. And this 6 is in the tenths place. This 4 is in the hundredths place, so 4 hundredths. Okay, that looks like a really small decimal, and this is a really small fraction. All right, I see it looks like a 72, and it goes up to the hundredths place. So 72 hundredths. All right, flipping over to the back. Here we go. It says to add or subtract. And before you can add or subtract, you have to make the denominators the same. If you multiply the top and bottom by 10, this is really easy. 5/10 is the same as 50 hundredths. And remember, you never add the denominator. Okay, so if it's a 100 in the problem, it's got to be a 100 here in the answer. You only have to add 50 plus 31. There we go, 81 hundredths. Okay, again, if the denominators are not the same, make them the same. But they already are. This one's easy. Okay, here we go. I'm going to add the whole numbers first. A big old 3 plus a big old 4 is a big old 7. And then the fraction part, 1/8 plus 4/8 is 5/8. You just have to add the numerators. The denominator stays an eighth. Okay, now this fraction is a little bit hard, this subtraction problem, because you can't do 1/5 minus 2/5. So I would change this mixed number into an improper fraction. So this 1 whole is worth 5/5. So if I add 5/5 to this 1/5, I can change 1 and 1/5 to an improper fraction, 6/5. 6/5 minus 2/5. Remember, the denominator stays the same. We just have to do 6 minus 2, which is 4. All right, if the denominators are not the same, let's make them the same. Then and only then can we subtract. The denominator stays the same, and we're just going to do 48 minus 20 is 28. All right, we're multiplying 3 times 1/4. That's like having 1/4 3 times. So here's 1, here's 2, here's 3. Now, when I was little, my teacher said, put a 1 underneath and multiply straight across. And I said, okay. But you also really should understand that 3 times 1/4 means 1/4 3 times. Okay, if I multiply straight across, I'll get the same thing. 3 times 1 is 3. 1 times 4 is 4. 3/4 is the answer. All right, 5 times 2/4 means let's do 2/4 5 times. Okay, so I could draw a picture. Let's draw 2/4. Here's 2/4 once. Here's 2/4 twice. Here's 2/4 3 times. Here's 2/4 4 times. And here's 2/4 5 times. Okay. But when I was little, my teacher said, just put a 1 underneath and multiply straight across. And I said, okay, 5 times 2 is 10. 1 times 4 is 4. So I could write 10/4. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10/4. I also could write a big old 2 and 2/4. Okay? All right, 2 more problems. Carla is sewing 2 buttons on her shirt. She has 3/8 of a yard of purple and 1/2 a yard of pink. 3/8 a yard of purple, 1/2 of a yard of pink. Okay, which piece is longer? So we're comparing 3/8 to 1/2. 3/8 of purple, 1/2 pink. Remember, if the denominators are not the same, make them the same. I can make a 2 into 8. That way it'll match this one. 2 times what is 8? 2 times 4. And if you multiply the bottom by 4, you better multiply the top by 4. 1/2 is the same thing as 4 out of 8. So what's bigger, 3/8 or 4/8? 4/8 is bigger, which means the pink thread is bigger. All right, the very last one. Jim ran 65 hundredths of a mile. So not quite a mile, just part of a mile. Natalie ran 3/10. Who ran farther? Okay. 65 out of 100. 65 hundredths, sorry, is Jim. And Natalie is 3/10. Okay, it's really hard to compare two things when they're kind of different. If you can make them a little bit more similar, they're easier to compare. So if the denominators are not the same, make them the same. If you multiply the top by 10 and the bottom by 10, 3/10 is the same thing as 30 hundredths. Now that the denominators are the same, it's really easy to tell that Jim is the higher number. Okay, then it says, how much of a mile did the 2 children run in all? What's great about adding or about this problem is that I just need to add them. And if I use what's up above, I already made the denominators the same. And I would have had to have done that anyway to add them. So this work up here is also helping me with part B. Remember that the denominator stays a 100. You really just need to do 65 plus 30 is 95. 95 out of 100, would that be a good test score? Yeah, 95 hundredths is almost a full mile. So together they almost ran 1 whole mile. All right, here are the answers to side 1, if it'll stay focused here. And the answers to side 2. All right, I hope you did well.